Today's lesson is on solving quadratics by graphing. The objectives of today is to solve quadratic functions by graphing. Let's backtrack and take a look at when we solve linear functions. Here we get rid of the set of parentheses as our first step by distributing the 2 through. So we get an equation of 2x minus 6 equals 10. When we're solving an equation, we're balancing both sides. So we're getting the variable on one side and the numbers on the other. Here we'd add 6 to both sides, giving us 2x equals 16. And then dividing by 2, since we have a coefficient of 2 in front of x. Dividing by 2, we get our answer of x equals 8. Let's talk about a different way of solving this problem. Let's backtrack and go back to where we use the distributive property. And we got our equation of 2x minus 6 equals 10. Another way you can solve this is by setting it equal to 0. Notice how we have a positive 10 on the right-hand side. If we set this equal to 0, we'd subtract 10 to both sides, giving us an equation of 2x minus 16 equals 0. Notice how the left-hand side is in slope-intercept form. In fact, our slope is 2, and our y-intercept is negative 16. If we were to graph this linear equation, we'd know that it's a diagonal line where our y-intercept is negative 16 and we have a slope of 2. But notice something special about this diagonal line. Can you notice where it crosses the x-axis here? In fact, it crosses right at our solution of x equals 8. As a point, that'd be 8, 0. This is another way of solving these types of problems, is setting it equal to 0. And that's essentially how we solve quadratic functions. Setting it equal to 0 and solving for x. So, when we have a quadratic, remember it's a U-shaped graph. So in this case, we have our parabola, and notice it hits twice. It hits at negative 2 and 1 along the x-axis. These are our solutions. These are our roots. These are our zeros, we say, to a quadratic function. So we say x equals negative 2 and x equals 1 are our solutions to this function. In fact, you can have other cases as well. So we've already seen the case twice along the x-axis. We call that two real solutions. We also have a case with quadratics where it only hits once. That's where our vertex actually lies along the x-axis. And then we have this unique case where it doesn't hit at all. In fact, it never crosses the x-axis. So we say there's no real solutions, but in fact there is what's called a complex solution that we get later on in the unit. But let's focus on the first two situations. So let's take a look at this example. Here we have 2x squared minus 3x equals 6. The first step in solving a quadratic equation is to set it equal to 0. Notice how we have positive 6 on the right-hand side. So to move this to the other side, we need to subtract it to both sides. By subtracting it, we get 2x squared minus 3x minus 6 on the left-hand side, and we get equals 0 on the right-hand side. Once we set it equal to 0, the next step is to graph it and find these zeros. So, on our graphing calculator, we'll go to the y equals. Let's plug in the equation, 2x squared minus 3x minus 6. Now remember, we need to go to our standard viewing window, so go to zoom, number 6, standard, and we get our parabola-shaped graph. In fact, we notice that it hits in 2 spots, so we have 2 solutions here. So let's go ahead and find these. Remember, on our gateway 2, we go to second trace, go down to the option of 0 to find these x-intercepts. Remember, the first step is to get our cursor as close as we can to that point. Remember, it's asking for left bound, so we click left once, enter, and then twice right, enter, so that we're past that point. If we press enter one more time, we get our answer of negative 1.14 roughly. So let's do the same process to find the other 0, which is on the other side. So we go to second trace, go to our 0 option, press enter, get our cursor as close as we can to that other point where it crosses the x-axis, where our other solution would lie. It's asking for left bound, so we press left, enter, twice right, like we did before, enter, and then enter one more time, giving us an answer of 2.64. So our solutions here would be negative 1.14 and 2.64 to this quadratic function. Let's take a look at another example. Here we have negative 6x squared plus 5 equals negative 4x. Now we want to, again, set this equal to 0. So notice how we have a negative 4x on the right-hand side. To move it to the other side, we need to add it. So putting it in standard form on the left-hand side, we get negative 6x squared plus 4x plus 5 equals 0. Once we set it equal to 0, again, like last time, we need to graph it and find these zeros, find these x-intercepts. So again, on the calculator, we're going to go to y equals. We're going to plug in the equation, negative 6x squared plus 4x plus 5. We're going to go to our standard viewing window, so zoom 6. And we'll see again we have a U-shaped graph, but this time it's upside down. But again, we see that we have two solutions again. So let's find those. So press second trace, go to our 0 option, enter. Get our cursor as close as we can to the first solution, where it hits the x-axis. It's left bound, press enter. Twice right, so that we're past that point, press enter. And then press enter one more time to get our answer of negative 0.64 roughly. We need to find that other solution on the other side, where it crosses the x-axis. So press second trace again, going to our 0 option one more time. Getting our cursor as close as we can to that point. It's asking for left bound, so let's press left, enter. And then twice right, so that we're past that other point, enter. And enter one more time, and we get our last answer of 1.31 roughly. So our two answers here would be negative 0.64 and 1.3. These would be the solutions to this quadratic equation. Let's take a look at a more serious note. Here's an example. It says Mr. McNally is in a big air event at the X Games. And this is actually a true story back in 2006. On my off time, I do like to snowboard. But in this big air event at the X Games, I performed a flawless double McTwist and I landed it, earning me a gold medal in that year. In fact, the equation of this vertical motion can be represented as h sub t equals negative 6t squared plus 45t plus 25, where t is given in time in seconds. In fact, we investigate more vertical motion with quadratic functions later on in the unit. The question is, how long was I in the air for that jump? Now, if you don't believe me, I put a little rendition of some of my greatest works in my jumps at the X Games. So without further ado, here you go. So, that was just a little taste of what I do on the weekends. Anyways, back to the question. So the equation we had was h of t equals negative 6t squared plus 45t plus 25. Remember, the first step in solving a quadratic equation is to set it equal to 0. Now, why do we want to set it equal to 0 in this case? Well, remember, our output is height. So if you think about something falling in parabolic motion, okay, as in my big air event jump, landing on the ground would be at where my height is 0. So setting equal to 0 makes sense in this problem. So let's take a look on the calculator. If we're going to our y equals, like last time, and we plug in the equation, instead of t, we use x as a variable to represent time. We have negative 6x squared plus 45x plus 25. If we go to our zoom standard, zoom 6, you'll notice that the parabola is off the charts here. In fact, it's very hard for us to see when I reach my max height. So, in fact, I think if I remember right, at the X Games, I think I broke the record at the highest jump. So I know for a fact that I was above 120 feet. So let's make our Y max in our window a little bit above that. So let's make it 150 here. So if I press graph here, you'll notice that I see the full parabola here. In fact, I see my maximum point. And what's really nice about this is it actually mimics our vertical motion. In fact, the y-intercept here represents where I took off from the jump. which is 25 feet. And you see that I reached the maximum height there of a little bit above 120 feet, and then I hit the ground roughly where it hits the x-axis. So that's what we're going to find there. We're going to find the 0, which will tell me how long I'm in the air. So again, press second trace, go into our 0, enter, and then let's get our cursor as close as we can to that point at which it hits the ground, which is close to the x-axis there. We use our left bound, press left, enter, and then we want to do twice right, enter. So we're past that point, enter one more time, and we see that I was in the air for a total of 8.02 seconds, which is one of my longest jumps. So this concludes the example. Hopefully you learned some things from this lesson. Come tomorrow ready to practice and get some more work with solving these by graphing. Hopefully you enjoy your night.